We have a very interesting talk today. I've got a team of people here from Hochschule Bremen in Germany, a digital media group, and Michael Latke is going to introduce the team since I probably can't pronounce Lovichak.
Hello. Nice that so many people found its way to the Google Tech Talk. My name is Michael Latke. That's the American pronunciation. The German one is quite hard. Okay, and let's not make more funny jokes about that. I'm a student of Jörn Lovichak at Hochschule Bremen Digital Media Master Group, and this is Sebastian Heise, also a student of Jörn Lovichak. We have been doing other stuff before we were students again. I've been working as an audio engineer for Audi and Bang & Olufsen. Sebastian was a sound designer for a company called the Gauselmann Group, which makes gambling machines that you can find in Las Vegas. And so he's responsible for the sounds that you hear coming out of these machines. And telling you what Jörn Lovichak did would fill more than 1 hour of talk time. So let's just say he's a professor for computer graphics. That was my introduction. Thanks. The Digital Media Master Group that we're in should be able to change slides. Yeah. Our aim was to find novel approaches in sound exploration. And so we did this acronym, but the meaning of the acronym changes whenever we want to do something else. So it was something else before, and I'll try to give you a short introductory problem. Think of yourself being a sound designer working on a movie score, and you have to do the sound design for one of the dinosaurs that shows up. Think of Jurassic Park. I think everybody has seen this movie. And what would you do if you search for a sound that should go along with this dinosaur? You have a huge audio database, and you just cannot type in dinosaur because there's no recording of a dinosaur available, not that we know of. And so maybe you would start typing in animal or something, and you might come up with something like this. Just a bird, not really fitting to a dinosaur. And then you think, okay, maybe we need a more mean animal. It's a recording of a pig. It's still not a dinosaur. But if you being a sound designer, you know you have all your tools on hand and you know how to change that sound of a pig in such a way it gets a dinosaur. It's the same sound, just processed picture. The idea now is this process can take an unbelievable amount of time. You have, as a sound designer, 40,000, 50,000 sounds in a database. Hard drives are not that costly anymore nowadays. And to get an overview what you actually have in your database is quite hard. So the aim of our software development is to ease the daily work of a sound designer and try to help him to find sounds faster in a more convenient way. And to demonstrate you one of our first software prototypes that we come up with, I'd like to ask Sebastian Heise to present SoundTorch.
Okay, hello everybody again. I will present one of our prototypes that is dealing with searching in large and complex sound effects databases. So we in our group are focusing sound effect databases. We have in mind that most of the MIR guys are dealing with MP3 music files most of the time. We are dealing with sound effects. As Michael already said, it can be really hard to find a specific sound in your database. I don't really need to tell you that. So just imagine I have some part of my database with me. This is a common product from Sound Ideas. And if I have maybe this library here and I'm searching for a certain sound, maybe let's say I'm searching for bird, and I get in a list of something, you know, about, I think, 50, 60, whatever recordings, just what is tagged with bird. So even there are some better tags. I have to go through all these things and have to listen to it. And just, if you would say, okay, every recording is 1 minute and I go through it and listen to all that stuff, it would take about, let's say, 1 hour, just listen to everything. And then if you're at the last one, oh, what was the first recording or something like that. So this takes a huge amount of time, just listen to all that stuff. Or, you know, tagging is a problem. Back to the dinosaur problem. I'm just searching for dinosaur. Of course, I would just get an empty list. There's nothing, of course. Or I'm searching for a bell sound, you know? And I would say, I enter bell, and I just get a list with the helicopter sounds that are produced by bell because they are tagged. So this is a problem. So of course I had to search for brass bell or something, but so this is a problem, and we faced that, and we tried to come up with something else. We don't have that list view thingy that is common in all other media libraries. We come up with an icon-based thing. We put sound files of those bacteria-like thingies on a surface. And now we give the user something that we called a sound torch, a flashlight. So we have a flashlight stick to the mouse pointer, and you can resize it with the mouse wheel, in our case, whatever. We have a demo where you can control it with the remote control. It's pretty cool, so you can just add really that with the remote. But this is more for demo. So you have it on the mouse pointer, and if the light comes to that icon, it begins to play. Hopefully. No, it does not.
Play AU.
Something wrong with the sound?
Play AU.
No. Here we are. So, and maybe you wonder about the shape of that sound. This is just, imagine, you know that waveform images from your sound edit or something, you just wrap it around that circle. So the shape is formed by the audio power. And due to the spinning speed of that bacteria thingies, you can have an idea how long that sound. If it's a fast spinning one, then it's of course a very short sample. If it takes a longer time, this is a long recording, whatever. So, and you can browse, just easily browse, explore through your database by just drag and drop that surface. You see, you find other things, more interesting things. And what we do is that we have a virtual amount of speakers around that light circle. So you can set up easily that program with whatever, how many speakers you have. So we have a stereo system right here, but normally you would maybe have in a professional studio a 7.1 whatever surround system. So we stick those speakers around that light circle, and that guy here would be coming from the back left, and that one at the top coming from the front right, or something from the middle center speaker. So we use this well-known cocktail party effect, and the brain will just easily figure out if you're searching for a sound, which there's something there and something there, behind me, in front of me. So you're always sitting where that pointer is, so all speakers are around you. And of course you can zoom in and zoom out, and you easily can hear where is my favorite sound. If you're searching for something, you hear it because your brain just skip all the other things that you're hearing. So, yeah. So what happens is that you can zoom out and can listen to, let's say, much more than just one file at the same time. You can listen to 10, 20, 50, hundreds, whatever sounds, whatever you want to. The other thing is that, of course, you already see we had those small thunderstorm sounds right here in that corner. And we have some metal sword sounds right here. We distribute those icons on that surface by, that is not really rocket science nowadays, but just extracting MFCC's features, having a self-organizing map, and so we get a psychoacoustic similarity mapping. So we have always just groups of more or less, say, similar sounding things together on several parts of that surface. So, okay, we have here a small demo map with just a few sounds on it. But of course, I can load much more things. Let's say, so I just select another folder, and just to reload all that stuff. It takes a few seconds. And again, you can go over it with your flashlight and listen to all that stuff, and you're searching or exploring just your database. You have somehow some sounding sound with some crazy gunshots or whatever, some more dull sounds right in the right button all the time. This is what's happening. So, and we did some user tests with it to try out if it's really faster to find some things. And among others, we asked our subjects to say, can you find a certain pattern in that? So we play back a sound, something like this one, maybe. This is just a small, just this little small blip, and can you find it? So this comes due to, you know, if you're a sound designer, you often have your database and you know, I have that recording somewhere in it, but I've lost it, or something like that. But you know it is there, or you have a very good idea of what kind of sound you're searching for. So you have the sound in your mind, and you're searching for it. To simulate that, we said, okay, can you search for that blip sound? Sounds like blip. Going back to that map and say, can you find that blip and that map? So normally you should zoom out, take a certain flashlight size and go over it. And then, just after a few seconds, if you listen, you hear that blip. It's somewhere in there. So you know, okay, if you have that surround system around you, it's much more easy. You just go into it. If you lost it, you have to somehow resize. I don't hear it. Okay, here is it. So these are 160 sound files, and it takes a few seconds to find that certain pattern if you know it. So this is, I think that's amazing. And one could say, okay, that blip is somehow outstanding, and okay, you can hear it. Of course, I can load another map. So let's say we have another pattern. Can I play back this one somehow? Where is the play? No? So I have that ding-dong thingy, and I'm just loading another map again. list. Takes again some seconds. So we have a lot more of just instrument sounds on this map. You know, again, the more metallic things are on the upper left, and the dull sounds are on that corner. Timpani sounds, something like that. You get these clouds again, and you go over there. Always, I don't know if you remember that ding dong, but again, you just go over it. Somewhere in there, so we have a cloud with all these harp sounds and some ding dongs. But those three guys, there's the ding dong. I can again go in there. It is so. It turned out it works pretty well. Yeah, so much to SoundTouch. For the future, we try to enhance, of course, some implementation issues, putting more stuff to do with graphic cards or something. It's a hard thing to mix hundreds of files, if you listen to it, in real time always together, or can we do something with HRTFs, head-related transfer functions, with hundreds of files in real time, using the GPU or something like that. That's ongoing work in our project. With that, I will hand over to Jörn. Just close my things.
Okay, now you saw some bacteria-like icons. What I'm going to show right now is a work of two other students who created a different shape of icons for a different purpose. Namely icons that go along with MP3 music files. The idea is we can plug into Windows Explorer to create our own icons procedurally on demand, depending on the content of a specific file. So what we do is we look into the content of every MP3 file, extract acoustic features, namely MFCCs and some sort of rhythmic spectrum, beats per minute spectrum. And with that information, compose a procedural icon that is displayed everywhere where you see icons in Windows Explorer. I can show that. We've got that running on this machine. It's going to look like that. Whenever you open some folder that contains MP3 files, you're going to see these icons in different sizes. And the shape and the colors of these icons transport what's in them. So we do not attach labels to, say, genres or different sounds. We just create a sort of visual representation. For instance, let me go back to the symbols. For instance, you see that some MP3 files receive really similar icons. For instance, this one here has this brownish shape. Hopefully that's audible.
Is it audible?
Should be audible. It's not? Yes, it is. Okay, that's some kind of industrial techno sound, and this also is some kind of industrial techno sound. They receive the same shape. If you look at some heavy metal piece, this one here, it receives a pretty different shape, obviously. There's stuff in between, like this robot jungle piece, which is a blend, so to speak, between industrial sound and heavy metal sound. This kind of icon creation is based on a neural network. The user picks, say, 5 songs of his or her liking to define how those icons should be built. So think about your music collection as a landscape. You try to pick songs at the outer edge of this landscape. You define icons for them by controlling 8 parameters. These icons are controlled in terms of color, inner and outer color, and in terms of the number of petals and the shape of petals. This is what you define for, say, 5 songs. You train a neural network with that data, and then we use that neural network to create icons for every MP3 file that may be on that system. We extract the acoustic features from the MP3 files, use the neural network to look up which parameters should go along with those acoustic features, and create bitmaps in all sizes that are required, and hand them over to Windows Explorer. We did user tests on that. Question is, does visual similarity or dissimilarity translate to acoustic similarity or dissimilarity? And we found out that it pretty works out well. What we did is we actually printed those icons on cardboard and asked subjects to sort those cardboards by similarity. So what you see in the lower right are the clusters that users formed from those printed out icons. These are the clusters that one user formed, and these are the clusters that another user formed. So these clusters are pretty similar, and we went further. We played back the songs that...
It's just my computer.
Now the audio's gone. Do we have audio again?
Seems so.
Do we have audio again? Okay. We played back the songs that belong to one of these clusters and mixed in a song of another cluster. And this song pretty much stood out. The users were able to tell this song from all other songs. So we could verify that there is a relation between acoustic and visual similarity. We thought about how to extend these ideas. One extension is a two-dimensional arrangement. Once you've got flowers in your Windows Explorer, you may think about having fields of flowers. This sort of landscape, genre landscape, acoustic landscape has been done quite a lot in recent years. Here it combines nicely with the icons when we display them as some sort of flower field. They are pushed apart by some physical forces, physical simulation, to not form very dense clusters. Another application is for very crowded displays like this PDA. We can easily display 150 songs on one single screen by just showing those icons and nothing else. And now I hand over to Michael for file system tricks.
The last part of the presentation that will conclude somehow the overview of our recent research is called File System Tricks for Audio Production. What we try to do is, when we write all the software prototypes, we want to make a search result accessible for other software applications like Pro Tools or Nuendo or whatever you're using in your studio. And all these machines are file system based. So whenever you want to read a file, you cannot just read it out in SQL database. You have to read it from the file system. And there we got the idea of using virtual file systems. I think you here at Google all probably know what Fuse is. And we thought about how to make these files accessible if we have a search outcome from SoundTorch. And then we got so many more ideas about what we could do with virtual file systems together with audio content. And I'm just going to show you some of the demos that I brought here right now. The first application that we did was can't we just enhance the built-in search functionality of an Apple computer like Spotlight and these virtual folders to give us more audio-related search results? And we found out we can. It's quite easy to write Spotlight plugins. And we did music information retrieval applications for Spotlight. For example, you can search your music depending on the zero crossing rate of a file, which is just one short prototype of an audio music information retrieval application. The next question we asked us was, can we use Fuse not only on Apple machines or on Linux machines, as it was used a long time before, like procfs is a very old software. We wanted to use Fuse on a Windows machine, and we found out that, like, as far as we know, there are 5 projects going on right now that try to bring Fuse to Windows and Windows Vista. There's only one that we could really work with. It's the Docon file system driver. And we came up with some prototypes that should help you to work with audio on a day-to-day life with audio effects. The first thing we did was, we call it riff regions file system. If you have a WAV file for, let's say, 1 hour length, and you want to work with that WAV file, it is quite convenient to define regions in that WAV file where you can, for example, say, okay, now this guy is speaking, or now the band plays, or now the other guy is speaking. And this is just a part of the riff header where you can define that region, and you can name that region. And here I just did it for a Johnny Cash song, and it extracted all the different verses of the Johnny Cash song and the Cockaigne Blues. And here I still have the original, but I also have all the different verses as a single file, which is just virtual. So this file does not actually exist. It's a virtual file system. The Fuse file system grabs the region markers out of the riff header and displays a new file to the file system. Another application that we found is it might be convenient to have all your effects that you have installed on your audio workstation. These can be more than 300, 400 easily if you're working in a professional studio. Also accessible via the file system, which we try to do here. For example, you can open up the wah-wah effect as just a folder in the file system. And if you play back a file from that folder, the sounds will automatically be processed with the effect. Another thing we did, we call audio processor. Day-to-day life applications that you have to do as an audio engineer. For example, you have to normalize your audio files. If you drag files to these folders and read them back again from these folders, they will automatically process, and you can put these folders in one another, and you can, for example, like this, build yourself an own batch processing file system, which is thought of like an on-demand batch processing. I'm not going to demonstrate it because it crashes. Sorry. The last file system application that we thought of was if you're working in a studio, you very often have to face the problem that you have networked Windows Vista and Mac OS X machines. And in terms of file handling and project management, you want to have all your files in a different folder, and you want to have them accessible from all the machines. And you want to have the folders labeled maybe by your project names. And Windows Vista and Mac OS X comes with this virtual search folders, where you save a search, and whenever you open up that folder again, all the search files will show up in this folder again. The only problem that this system has, if you save a search on an OS X machine and you want to open this search again on the Windows Vista machine, you just see an XML file, because basically the search is just an XML file, and it works vice versa again. So we tried to address this problem as well by using a standard SQL database in the back end, where we have files tagged with project names. This is basically an enhanced MySQLFS that we hacked. And what we can do now is we can go into this MySQL database and see here we have 2 folders, all files and search. If we go into this folder, all files, we see all the files that we have. This is just a short demo in our whole studio. And we can, using the SQL database, tag these files as belonging to different projects. If we go back here into the search folder, and we see here we have no project assigned yet. If I make a folder now, denoted project A new folder is created. And in this folder, automatically, all the files that have been tagged with as being belonging to this certain project are showing up as virtual files again. This is, again, no rocket science. It's the same thing that Spotlight does with the same search on OS X and Windows Vista does with the same search. The good thing about this application now is you can export this file system just as an SMB share. And it turns up here again on every network machine and is accessible from everywhere. So we thought this is also quite convenient in your everyday studio life. That basically ends my presentation on file system tricks for audio production and also our presentation about enhanced audio search. Thanks you all for participating. And if you have any questions, feel free to ask them, and I'll be happy, and Sebastian and Jörn as well, to answer them, hopefully.
I have a question. When you arrange your sounds by psychophysical, psychoacoustic similarity on this 2D space, what kind of method do you use to compute that similarity? You mentioned it's kind of from bright to dull, but what are the dimensions and how is it computed, and do you train it, or is it some simple standard measure, or what is it?
Can I hand over this question to Sebastian, please?
You mean at SoundTorch, the distribution? So in a pre-processing step, we extract all the MFCCs with, let's say, a 10 milliseconds Windows frame size, and take the first 13 dimension of it. So 13 dimensions of MFCCs. And we take the median, so we have a whole bunch for everything. We take the median thing in the middle to for the, let's say, one-shot thing, to find a certain vector that we can use to put it on that surface. And then we take as most files as possible to train that self-organizing map with that 13-dimensional vectors, and that just trains itself and distributes it over that whole thing. That is.
So there are no fixed labels to the axis.
Yeah, there are no
automatic.
fixed labels. And that's, of course, you cannot. All the time you get a new self-organizing map with somehow changes, of course, because it's more or less random what's coming out.
I was wondering, that was a good question. That was my first question. My second question was on that same Torch application. It sounded like you said that the speakers are arranged around the user. But how do you decide what's in front and what's behind? And can you like rotate the plane so that something that's behind the user is now in front of the user?
So I'm sorry if I don't know something about the sound setup right in here. So we have this was the fallback stereo solution. So of course we just have 2 speakers, and I don't know how the speakers are arranged in this place. But
right, no, I understand the limitations of this auditorium,
yes.
But in the sound studio, what direction on that circle is the user facing?
Up is front.
Up is front.
How do you decide what sounds are in front and what sounds are in back?
Up is in front, down is behind you.
actually depends on here's the mouse pointer,
Right.
and
The user's head is
the
at
user's
the mouse
head
pointer.
is at the mouse pointer.
But so, how do you decide what sounds to put in front of the user and what sounds to put behind him? What if user likes to turn around? Can you do that in your tool?
Virtually we can, but we don't want to because it would break the system. It just works as the sound comes from that direction as you see it. Because then you know, I hear it from that direction, and then I can move my searchlight into that direction.
And if you turn your head, it's okay. If you turn the mouse, then it moves, which makes that cocktail party effect easier if it's always moving because you have moving sound sources. If it's a fixed image, so to say, then it's harder. So you can, the more you move with the mouse, the easier it is.
Next question, please.
So I've done some amateur audio design for things when I was in at uni, and SoundTalks looks really cool. Can I get it?
I think so, yes, of course.
Publicly available?
It's not publicly available yet. We have to fix a lot of installation issues and have to make it work on more graphic card. It already leverages quite a lot of graphic cards computation power, but it will be available.
Cool.
So it's based on the .NET 3 framework and written with the XNA thingy from Microsoft. But if you have a Windows machine, then it should be possible. So.
It's a decent graphics card.
Yeah.
Any further questions?